Blocking is a standard strategy for improving the precision of randomized experimental designs. In field trials, it is usually beneficial to impose blocks in both row and column directions. A common problem with classical randomized row-column designs is that replications of a treatment may be clustered together or appear as self-diagonals, and some pairs of treatments may appear next to each other rather more often than others. Such patterns adversely affect certain design properties, which we refer to as neighbor balance and evenness of distribution, and they may be particularly harmful if some of the treatments are very susceptible to environmental stresses. A spatial block design or row column design takes into account the separation of different treatments and blocks. I'll demonstrate how CycDesign adapts block and row column designs to achieve good neighbor balance and evenness of distribution. We'll use a row column example. From the menu, I'll select Non-Resolvable, then select the row column design. Click Parameters and enter 34 treatments, 9 rows, and 13 columns. Then click Next to close the menu. Set the other options to Not Spatial and One Stage. Then click Next. CycDesign now runs through a number of iterations to try to optimize the average efficiency factor of the design. In other words, it will try to create a design as close as possible to a theoretical upper bound that is displayed. I'll let this run for a few seconds, then click Next. At this point, normally I would select Randomized to generate a randomized design, but just for this demonstration, I'm going to deselect this option. Later on in the demo, this will make it easier for us to compare the treatment replications and to track the treatment numbers from non-spatial to spatial. In practice, though, you would normally select this option. I'll deselect the Randomize option and click Next to generate the design. This produces a near-optimal row-column design. We have a row-column average efficiency factor of 0.850. Notice the unequal replication of treatments. The first 19 treatments have 3 replications, and the last 15 have 4 replications. There are some concerns with this design. This mock-up of the CycDesign output illustrates the problems more clearly. The design has poor evenness of distribution, with replications of treatment 21 clustered closely together in the middle columns. Additionally, there are multiple instances of diagonal self-adjacencies. Treatments 10, 15, 21, 25, 29, and 31. We also have poor neighbor balance. Treatments 8 and 32 are adjacent in rows 3 and 4. Treatment 8 only spans 4 of the columns, and treatment 10 spans just 3 of the rows. We assume that plots are usually long and thin, with a greater number of columns than rows, and so adjacencies within the same row are of primary importance. To address the problems of neighbor balance and evenness of distribution, I'll run through the process again, but this time select the spatial option. I'll fast forward through the process so you can see the resulting output. Comparing this to the previous design, we can see some spatial improvements. The treatment adjacencies of the previous design have been eliminated. The neighbor balance score is now 0 rather than 1. The minimum span is now 8 columns and 6 rows, compared to only 4 columns and 3 rows for the previous design. We have a slight reduction in the average efficiency factor, but this is compensated for by the improved neighbor balance and evenness of distribution.